Okay, today we're doing operations with complex numbers. So you have to learn what a complex number is. And voila, here it is. A complex number is the highest number of known number to mathematicians. It's when you take a real number and combine it with an imaginary number. You get a complex number. Now notice these cannot be added together. An example of a complex number would look something like 3 plus 4i. 3 parts real, 4 parts imaginary. Much like you could not add together 3 plus 4x. So if I gave you a visual, the highest known number is complex. And we have two sets of numbers. We have the set of real numbers, and then we have the set of imaginary numbers. And imaginary numbers, remember, are square roots of negatives. And in fact, it's more than just square roots of negatives. It's even roots of negatives. But we in Algebra 2 are only going to deal with square roots. So the real numbers, this is your entire math career. When you were little, right in here, these natural numbers, that's what your parents did to you. They sat you down, they went, okay, little Philip, let's see if you can count. 1, 2, 3, yay! And then, nobody ever taught you to count starting at 0, did they? 0 was introduced after you learned your numbers. And then you probably did natural and whole numbers up to 5th grade. And then suddenly in 6th grade, they introduced negative numbers to you. And then somewhere around 7th grade, we started talking about rational numbers, repeating decimals, fractions that can be expressed as decimals, decimals that can be expressed as fractions. And then all of a sudden in 8th grade, we introduced irrational numbers, numbers that aren't perfect squares. But all of those numbers were part of the real system. And now here in 10th grade, we introduced the last known number, the imaginary number. All right, so when anybody invents something new in math, it still has to abide by the existing laws. You can't make up new laws. So in this chapter, you're going to add, subtract, multiply, and divide complex numbers. So right here, it's asking you to add these complex numbers. Here's the first complex number, because it's got a real part and an imaginary part, and it's adding me with this complex number that has a real part and an imaginary part. So the 3 can be added to the 6. The negative 4i can be added to the negative 2i. And what you have is a new complex number, 9 minus 6i, because negative 4 plus negative 2 is negative 6. If you're subtracting complex numbers, it's the same way. We'll look at the real parts. 3, take away 6. That gets me a real part of negative 3. And now let's do the imaginary parts. So the imaginary part is a negative 4. Take away a negative 2. So that imaginary part ends up being negative 6i. And there's my new complex number, negative 3 minus 6i. So you get it. All right, multiplying. Here we're multiplying a binomial by a binomial. So this would be my ugly FOIL word, or double distribution. It still has to be the same laws. So 3 to 6 is 18. 3 distributed to negative 2i is negative 6i. Negative 4i distributed to 6 is negative 24i. And then careful, negative 4i distributed to negative 2i becomes a positive 8i squared. Okay, sorry, I had a little interruption there. Somebody came in the classroom. But getting back to this, I left you off right here at I squared. And I brought out our friend the clock. So if I start combining like terms over here again, I see that my imaginary can get combined to negative 30i. This 18 is a real, so it doesn't get combined. But I squared, if I look down here in my clock, I squared is negative 1. So an I squared took that and turned it into a real number. So now I have 18 minus 30i minus 8. So I can combine these two real parts right here, and that ends up being 10 minus 30i. So I have 10 real parts and negative 30 imaginary parts. All right, here comes the little tricky one. Allow me to explain this. Dividing complex numbers. If you remember, I was Gauss's way of saying, whoops, there's the bell, the square root of negative 1. So technically, if I rewrote this, this is what I have. 3 minus 4 square roots of negative 1 over 6 minus 2 square roots of negative 1. And for my math geniuses in the crowd, which is all of you, you suddenly should say, I can't have radicals in denominators. It's bad to have radicals in denominators. Remember when you had something like 3 over radical 5, you had to rationalize the denominator? Well, you have to rationalize this denominator also. And you have to go back and you have to use your conjugates. Yes, words that come back to haunt you. So, when we divide, we multiply by the conjugate, and that means to change only the middle term. So here we are, multiply by conjugate. All right, so we multiply by the conjugate. We're back to foiling, double distributing. If you remember the secret that happens on the bottom, that's 36. That's positive 12i. Hopefully some of you are remembering the shortcut. If I distribute the negative 2i, that's right, here's the shortcut right here. The middles fall out. So if I were to clean that up, my bottom would be 36. The middles cancel out. I squared is really a negative 1, so this really turned into a plus 4. So I really had a 40 on the bottom. Okay, let's quick FOIL the top. 3 times 6 is 18. Plus 6i minus 24i minus 8i squared. Okay, let's clean that up. Positive 6i and minus 24i is a minus 18i. But remember, I have my I squared over here, and I squared is really a negative 1. So this turns into a plus 8. So now I have a real number, with this real number gets me 26. So I have 26 minus 18i, but I'm not done because it has to apply all the rules. So 26 minus 18i over 40. I have to look at my real part, and then I have to look at my imaginary part. And these are fractions, and the rule with fractions is they must always be reduced. So I still have my one step of reduce this by 2 and reduce that by 2. And that is my complex number when I divide it. All right, see you tomorrow.